Hey everyone, and welcome to this explainer. Today, we're diving straight into the secure dev paradigm. We're going to completely transform how you think about building software, right from the ground up. Look, if you write code, whether that's for the web, mobile, or backend services, you are exactly in the right place. And more importantly, you are the crucial first line of defense. Because the harsh reality is, every single day, somewhere in the world, an application gets breached. And we aren't just talking about fancy firewall bypasses or complex network intrusions here. We're talking about the application itself, the very code that someone, just sat down and wrote. Think about Equifax, SolarWinds, or that massive Log4j catastrophe. The uncomfortable truth, the vast majority of these massive breaches exploit totally preventable coding mistakes. Things like SQL injection or leaving secrets exposed in your source code. Right now, attackers are finding that first line of defense way too easy to cross. And that brings us to the classic developer's dilemma. I mean, we've all heard the excuses, right? Actually, scratch that. Maybe you've even used them yourself. I'm not a security expert. I just build features. Or, hey, our sprint ends Friday. We absolutely do not have time for a security review. Or my personal favorite, we have a security team for that. Well, let's look at the reality. Security teams can audit and advise all day long, but at the end of the day, they don't write your code. You do. A single vulnerable API endpoint can lead to a data breach that costs literally millions in fines, lost customers, and just severe reputational damage. Plus, modern regulations like GDPR and PCI DSS, they hold organizations legally accountable for software security. The code you ship has very real, very serious consequences. And the economics of all this? Absolutely brutal. Get this. According to the Systems Sciences Institute at IBM, fixing a bug in production costs roughly 30 times more than it does to fix that exact same bug during the development phase. 30 times! Just to put that into perspective, if you wait for a vulnerability to make it all the way to production before you address it, you aren't just fixing a typo. You are draining budgets, wasting immense amounts of time, and putting the entire organization at enormous risk. So what do we do about it? Well, this brutal economic reality leads us directly to the core philosophy of modern development. It's called shifting left. If you picture the software development lifecycle as a timeline flowing from left to right, shifting left means pulling your security activities away from the right side, where all the testing and deployment happen, and dragging them all the way over to the left side, the side where requirements, design, and coding actually start. By integrating security early, you find bugs when they are incredibly cheap and easy to fix. It completely shifts your daily workflow, turning us from reactive problem solvers into proactive defenders. Think about it like building a house. When you design a house, you don't wait until someone breaks in to think, maybe we should install locks on the doors. You don't wait for a kitchen fire to decide where the sprinklers go. And you definitely don't pour a concrete foundation and then step back wondering if it'll actually hold. Security features, the locks, the alarms, the fire-resistant materials, they are drawn into the blueprint from day one. Building software is exactly the same. Things like authentication, input validation, and encryption, those are the locks and alarms of your app. If you try to just bolt them on after the house is built, they're going to be expensive, incredibly weak, and full of gaps. To truly shift left, you kind of need to adopt a dual mindset in your daily routine. First, you have to think like an attacker. This means constantly asking yourself, okay, if I wanted to break this, how would I do it? What inputs could I manipulate? What underlying assumptions could I exploit? But you combine that with building like a defender. You treat security as a core feature, not an afterthought. It means accepting out of pure professional responsibility that every single line of code you write could potentially become a vulnerability. Now, to execute on that mindset, you need a highly actionable security toolkit. When you build securely by design, you eliminate entire classes of vulnerabilities before they ever see the light of production. Mastering secure coding principles means tackling input validation and proper error handling head-on. You also need to deeply understand API security for both REST and GraphQL since, let's face it, APIs are massive targets today. You should demystify protocols like OAuth 2.0 and OpenID Connect. And absolutely crucial here, you need a firm grasp of the OWASP top 10 so you know exactly how to prevent those top threats in your specific code base. Now, if that sounds like a daunting syllabus, let me completely reassure you. Here is what you will not need. You don't need any highly specialized security tools. We're focusing on core concepts here, so zero vendor lock-in. You don't need any prior cybersecurity certifications like a CISSP or CEH, and you absolutely do not need an advanced background in mathematics or cryptography. If terms like elliptic curve make your palms sweat, just relax. You already have exactly what it takes, your existing development experience and your natural curiosity. I want to ground this whole explainer in a really powerful quote from Bruce Schneier. He's one of the most respected voices in cybersecurity, and he said, "Security is a process, not a product." There is no silver bullet. There's no single library you can install or a magic checkbox you can tick that will make your application secure forever. Security requires an ongoing practice of defense in depth. Every single layer you add just makes the attacker's job that much harder. All right, let's do a quick check to see if this mindset is locking in. Question 1. Who is actually responsible for application security? Everyone involved, it is a team sport. The whole "that's someone else's job" myth, that ends today. Developers write the secure code, security teams test it, QA validates it, and leadership prioritizes it. Every single person plays a part. Okay, next up. When exactly should security be considered in the development process? From the very beginning, day 1, line 1, threat modeling needs to happen right there during the design phase. Waiting until after deployment is exactly how you end up in the negative headlines. Finally, the golden rule. Let's recap. What exactly does shift left mean in security? Address security earlier in the software development lifecycle. Pull it right out of the testing phase and inject it directly into your requirements and coding phases. This is your ultimate key to proactive defense. It catches bugs when they're cheap and builds a truly robust foundation. So I'm going to leave you with a provocative thought to carry with you. When you sit down at your keyboard on Monday morning, I want you to look at your screen and ask yourself, is your next line of code a feature or is it a vulnerability? Because the reality is, it's always one of the two. Embracing the shift-left paradigm, mastering those secure coding principles, and keeping that defender's mindset, that's what will ensure you're always building features, not backdoors. I really hope this explainer has left you eager to master your toolkit and dive deeper into the OWASP Top 10. Stay curious, stay secure, and keep building great things.